A human-machine interface (HMI) is a user interface or dashboard that connects a person to a machine, system, or a device. While the term can technically be applied to any screen that allows a user to interact with a device, HMI is most commonly used in context of an industrial process. HMIs are similar in some ways to graphical user interface, but they are not synonymous. GUIs are often leveraged within HMIs for visualization capabilities. Similar to how you would interact with your air conditioning system to check and control the temperature in your house, a plant floor operator might use an HMI to check and control the temperature of an industrial water tank or to see if a certain pump in the facility is running correctly. HMI devices use various different communication protocol to interface the control screen with the sensors and actuators. In this video, we are exploring an example of interfacing PC with XMC4700 Relax Kit through USB port. This example demonstrates the implementation of USB HMI device. It is based on Luffa USB stack and Luffa HID class drivers. A Python application running on the host PC is used to control the peripherals in XMC4700 Relax Kit. XMC4700 Relax Kit is connected to Dev ID using the debug USB port. The USB stack application running on XMC Relax Kit interacts with PC through USB HID connector given on the other end of XMC Relax Kit. PYWIN USB package is used in the Python application to interact with XMC Relax Kit. USB application in Dev ID is used to implement USB LUFS stack and access the USB low-level drivers. We do not need to assign the pins to the USB app because internal hardware dedicated pins are assigned without secondary functionalities. Digital I/O apps are used to access the input and output ports. Two ports are used to control the LED1 and LED2 of XMC4700 Relax Kit. Two ports are used as input to read the status of button 1 and button 2 of XMC4700 Relax Kit. The Python script sends a HID report to the device. By clicking the connect button in the GUI, we shall connect the XMC4700 Relax Kit as the USB to the application. The toggle buttons B1 and B2 are used to control the LEDs in the XMC Relax Kit. The GUI sends a HID report to the XMC4700 Relax Kit when the switches in the GUI are toggled. The LEDs are turned on by the app in the XMC4700 Relax Kit based on the HID report received from Python GUI. Similarly, the Python script receives a HID report every time the push button 1 or the push button 2 in XMC4700 Relax Kit changes their state. When the switch in the XMC4700 Relax Kit is pressed, a corresponding LED icon is turned on in the GUI based on the HID report. The application in XMC4700 Relax Kit generates a PWM signal of 1 kHz with 50% duty cycle. When the slider position is changed, the Python GUI sends a HID report to the XMC4700 Relax Kit. The app in XMC4700 Relax Kit has a 1 millisecond timer that triggers an interrupt periodically. The interrupt service routine is used to update the duty cycle of the PWM signal. The PWM signal can be observed on the oscilloscope. Hence, through this application, we can see the interaction between a USB-based HMI device and HMI control application based on Python. Thank you.